Let's begin with question number 2, okay, from the OMK 2021. These are section B questions, surely, I guess so. And this is the harder types, okay, and it's the Malaysian National Mathematical Olympiad 2021, question 2. So they say, let's read the question together, please. It says that find all triples ABC such that a cube plus b cube plus c cube equals to ABC whole thing square. That means they want triplets that satisfy this lah. A cube plus b cube plus c cube equals to AB square, where ABC are positive integers. Solution using trial and error method is not acceptable. It's not a mathematical reasoning lah. Okay, it's quite a common thing. So they put it here very clearly. Please take note. Okay, let's start with the first image. It worked out earlier. Let's begin with that, please. So what we need to do is, this is a symmetric equation. That means whenever you replace the A, B, and C, the letters, it doesn't make any difference, it's the same. So we can assume without loss of generality, that's called the VLOC here, without loss of generality, the abbreviation, A less equal to B less equal to C. So we put some ordering, because regardless which is called as ABC, we can relabel. So the idea of relabeling, why would we want to use that? Because an extremal argument, where sometimes by considering, because the number is going to have the order regardless. So by considering the order within it, we can get certain limits. And the limits, when in turn, would cause some solutions only. Okay, talking about solutions, please take note, this is just my personal look at it. I did not look at the solution, I don't have it. And just a question here. So if any part is wrong or anything I missed, it's purely my mistake alone. Okay, thank you. Okay, let's continue, please. Just sharing some ideas. Okay, so A, B cube. So we just changed it to an inequality here. Just change the A and B to its extreme. It could be at most C1. So replace the A and B with the C, get 3C cube. Play with the, and this one is equal to 3BC, ABC square. So when you rewrite the inequality here, remove the C square and C cube. Becomes a C here. Turn it in AB square there. So this is inequality 1. So I'm just labeling it. Later I'll use it, you'll see. Okay, and then on this side, I just break up this equation because based on an integer argument. So we factor out the C square separated, bring to the left like that. So these are integers. When you rewrite it, these two parts are integers. So the thing on the left there, it's a difference of two integers. So itself, it must be an integer. That's the logic. The difference of two integers is an integer. So how can that be an integer? So A cube plus B cube is divisible by C square. That's what it tells me to make that an integer. So we can write it like this. Let's A cube plus B cube equal to LC square. For those of you who are new a bit to this, then you can see the LC square is bigger equal to C square, because L is a positive integer, L bigger equal to 1. So by writing this as an inequality, that's why I read this line here. The orange one is just a reasoning to help us understand that more clearly. Okay, let's have a look at that. So A cube plus B cube, but A cube plus B cube is going to be less than this. So this is where the extremal argument, because numbers have hidden order. So this is going to be less than, if you replace the A with the B is bigger than A, so it's 2B cube. So putting this together, so C square on the left hand side here, and the 2B cube here, putting this together like that, we get removing the A cube plus B cube, which is the link that links the two things, the two inequalities. Sorry. So C less equals to root 2B3 over 2 like that. So I multiply this by 3. Why I'm doing that? Because I'm just trying to match these two. If you look at it, because the other one is in 3C. Just playing with the constant, multiply. Then we combine 1 and 2 at the top. Ta-da-dan, ta-da-dan. Okay, this is what is happening in this third step here. So you combine the A and the 1 and 2, you get something like this. So we move it. You can see the A square B and a half, just normal simplification algebraically, is that 3 root 2. So this thing is less than 3 root 2. And I just do a simple proof how to show that 3 root 2 is less than 5 without a calculator. So that's how you can do it. You can write that proof in reverse also. Observe how I do it. Please take note. Why do we want to prove that? That means we get the remarkable inequality 3. This is an important one because it tells me that, please think about it, like a square and a square root of two positive integers, the product is less than 5. That means very small numbers, right? So that means immediately we can take the, because the B is at least 1, so that means because being positive integer, so we use the inequality here to show further that A square is less than 5, strictly less than 5. So A square strictly less than 5 means A is equal to 1 or 2 only. So we established that A regardless is going to be the smallest number in that equation is always going to be 1 or 2 only. That's what it means, according to that initial assumption of A less equal to B less equal to C. Okay, let's go for the second image to continue on this, please. Okay, let's see. So the second one begins like this. Okay, using that inequality with the case A equal to 1, that means recap inequality 1. Please refer to the video earlier. This, in case you need to look back, then you know where to see this inequality. Whenever it's quoted, like inequality 1 like that. So we just substitute A equal to 1, it becomes B squared is less equal to 3C. I just square it. Why am I squaring it? Actually, I already play with it. So I'm just writing a formal solution. Later, you'll see why. Because 3 and 4 I can combine. The reason because I want to make the 9C square is less than 18B cubed, which also did on the earlier page. Please have a look at that. So B to the power of 4 is less than 18B cubed. That itself is kind of interesting because actually the 4 is getting from here. It's not on the earlier page here. The right hand. That means this one, this 2 and 4, 2 is from the earlier page, is to create this upper bound. 9C square is less than the orange one, 18B cubed. Okay, that's how we prove that from the earlier one to this. So B to the power of 4 less than 18 cubed, when you divide that by B cubed, you get B less than 18. Another nice one. In a way that we know now that it is going to be B is less than 18. So a lot of lists, right? How to get a stronger inequality. So I know already B is limited also. So let's rewrite the equation with A equals to 1. So this takes a bit of effort. So let's just put it in. Then I just rewrite this. And I notice that B cubed plus 1 over C square needs to be an integer, this part, by rewriting with the 1 here. So therefore, we know that C square divides B cubed plus 1. And we know that we can do the inequality trick. So C square is less or equal to, a divisor of a number is less or equal to the number itself. That's why C square divisor is less or equal to the dividend of the number, which is B cubed plus 1. At most is itself only 1. Okay, so multiply by 9 again. Why is multiply by 9? Just to manipulate it to make it equal to 9C square, which you see the corner here, like the inequality 4, things like that. So that's why it's being repeated. Then combine 3 and 6, as you can see. So 9C square becomes the missing link kind of thing, linking this one, B to the power of 4 less than that. And 9C square tells me with the substitution of A equals to 1, this new thing. Can you see that? It links the things then completely with B alone, the red ones. Ta-da! Meaning that I only write this corner and less equal to this corner. Ta-da! Okay, let's have a look at that, please. So B to the power of 4 less than that. Then playing around with that, notice that B is, for B bigger equal to 10, this inequality does not work. How do I know that? So it's a proof here, in the right corner here. So this is the proof why that inequality doesn't work for B bigger equal to 10, which needs to be satisfied. That means inequality 7 does not work for B equals to 10. How do we prove that? You can see that just rewriting a bit of clever rewriting, B cubed, then the B cubed, I use the bigger equal to 10 because we already assume if B bigger equal to 10, what happens? So this part is used at this step. Can you see that? The B, one of the B only replaces 10. Why replace that? It's quite a classical trick because the left-hand side already got a B cube. So the right-hand side got B to the power of 4, right? It was kind of right-hand side, okay? So I changed that only. So 10 B cube, 10, then blah, blah, blah. Split to 9 B cube plus, this one changed this B now to 10. And then what happens? That means it's bigger than 10 cube is of course bigger than 9 and 9B cube. That means bigger than this thing, 9B cube plus 9, which is exactly a contradiction to this, isn't it? Because we want it to be less than that. That's what I proved earlier. So this contradiction tells me that the only possibility for this to be true is if B is less or equals to 9, the only other option. So B equal to 10, you get this opposite. That means this is B to the power of 4. Please take note, bigger than that, but it's less or equal to. So both cannot be satisfied at the same time. Contradiction. That's why we say contradiction down here. Please take note. Okay. Now that means we establish on this image B is less or equals to 9. Okay, let's go for the next one, please. S3. There we are. So it's a bit better. B from lesser to 18, we made it to less equals to 9. I don't know if any stronger inequalities are possible. If it is, then it's great. Okay, so it's the best I could do to reduce the case trying. Now we just do case trying. So check for, I use the word check because it's not a random guess or a trial and error that is unguided, but it's reasonable. So A is 1 to 9, just B is 1 to 9, sorry. and a is 1 in each case. So you see that now it's completely an equation with c. But the problem is it's a cubic equation on the left in each of this and a quadratic on the right. Cubic equal to quadratic, so it's not easy. So we didn't go and try to solve the equation. Please remember now we use the fact that we are dealing with integers. So integer solutions, by rewriting, as you can see, the red section is the rewriting of that algebraically. Please double check in case I made any mistake. Okay, but it's not a big deal. The idea is what is important, not the answer, the learning and the ideas. Okay, let's look at that place. So when you rewrite all of this, on each of it, see c cubed, c squared, the middle numbers. So I'm just going to put a nice ring around these middle numbers because you can just divide by c to realize that each of these must have a, I want to divide by c squared, sorry. Stronger condition is better because c squared means the right hand side is still an integer. The c cube over c squared will be a c. I didn't write that because too cumbersome. But the middle ones will be like, first one will be 2 over c squared. Then the next one will be 9 over c squared, 28 over c squared. And all of that being a difference of two integers must be an integer as well. That means that is what I'm trying to write here at this step. Straight away, we can deduce things like this. Immediately, the c square is going to divide all those numbers on this thing. That means we're talking about the same thing if you notice. C square divides every single number in the middle. Ta-da! Okay, so c square divides 9. Aha! C square divides 2. C square divides 28 in that order. C square divides 65. Ta-da-da! C square divides 126, 217, and all that. So I just need to find the primes and the prime factors, and more so, I just need to make sure they have a square factor. Do you notice? Square factor is needed. So by checking manually, I realized that, like for example, actually at the top here, I did an example before we go into that part. I just realized that. So the example here, at this upper part here, this one is taking up from which line? Let's say we're taking this line actually, this equation from the somewhere the bottom corner here. Please take note this one. So I rewrite here at the top there, as you can see, c cube plus 344 is 49c squared. Aha. So then what happens is this one becomes rewrite it as divided by c squared to get this one. So which is c plus 344 c squared equals to 49. So 49 minus c is equal to just an integer. That means 344 over c squared is integer means c squared divides 344. Aha, etc. Same thing. That's the law I'm using. That's why I get this green part on this one. And then I look at the perfect square factors for 344. That's a little bit numeric. I had no choice. I have to do it manually. You can see the only two prime factors. Everyone got one perfect square factor, which is 1. And this one got one extra, which is 4. Aha. So no other factors exist. So I just manually put back the 1 and 4. That means I take the c is 1, square root it. Like whenever there's a 1, everyone you can try it 1. Because all of them is a prime factor 1, if you notice. C square is 1 means c equal to 1. Like 9, 4, as you can see, only certain, these two numbers only are repeating. No other factors. You don't need to really show that. In Olympiad at this level, they will just assume if you can list it, you know. Because these are just numeric stuff, okay? However you calculate. So c is 1 or 3. 2 or 3, sorry, 1, 3, 2, 3, you know, the kind of thing. All those numbers when you square root, put back in the original equation and check. Don't waste time trying to do anything else. Meaning that if c is 1 or 3, let's say I just take this line. Sorry, let me use a different color to contrast it. Okay, so c is 1 or 3, you put back in this equation, and then you just write these two equations. Can you see that? These two here, put the c, replace it as 1 or 3 and check. So it seemed to satisfy. That means if you can satisfy that, that means it's a solution. If it cannot satisfy that, it's not a solution. So that's why you see a list of blue writings there, that some of it are telling can or cannot. Or the ones that can, you must show the actual numbers. Cannot, no need is understood by the trial and error. It's not trial and error, sorry, wrong word. It's by the cases, arithmetic of the cases. So ABC, so there are only two possibilities here, 1, 2, 3 or 1, 3, 2, which I conclude at the bottom of this page. So just the one. So it's a bit tedious to do it even within the time, even if you know. And let's go for the last image to conclude on this to see whether we've got any other case, which is the case. This is case A equal to 1. So we need to do one last case, A equals to 2. And luckily, that's a bit easier. So we don't have this whole list of cases. If not, no choice. Okay, let's look at it, please. So what if A equals to 2? Just put the 2 there, 2 square here. Just rewrite the original equation by substitution. It become 2 cubed, blah, blah, blah. So I'm going to use the inequality 1. Remember, whenever recap, is AB square is less than 3C. Play with it a bit. Combine 1 and 2. Remember the 2 we recap from the earlier one. So just look back at that part. Just combine simple 3C like that. So 3C is forging the link to combine the left and right in terms of B. That's what is happening. Like here. So we can see this one combined with that. Play with it. Just a little bit of inequalities, basic inequalities. Okay, then what happens? So 4 root B is less than 3 root 2. Aha, then I play up here. Let's continue at the top here. Please take note. This one like that. Just move, play the algebra. 16B is less or equal to 18, it says. And it's pretty obvious that for B bigger equal to 2, 16 times 2 is 32. It's completely impossible for this to happen. Can you all see that? Okay, so that means this part is wrong. No more answer for this. So B must be at least 2 cannot means. So only possibility to check is B equal to 1. That's what written in orange here. This part. And then put the B is 1. So A is 2, B is 1. That's the only thing we check. So I just slowly write the equation back into the given one at the start of this, which is this. So you can see the blink. So you know which part we're talking about, all this. Just substitute. And we can see that it reduces to an equation entirely in C alone, which is this equation. Okay, let's look at that, please. Divide by C square, maximum perfect square factor, 9 over C square. Now let's talk a little bit on that. So 9 over C square, in other words, equal to 4 minus C. So what's happening in each of these arguments here, it's an integer. So this needs to be an integer as well. So if this is going to be an integer, isn't it obvious that the two things you can see, like one is positive, let's see, less equal to 4. Or you can argue, like how I'm arguing, that C squared divides 9. So C squared divides 9 means there's only what possibility? C squared is a perfect square factor. So meaning that it can only be C squared is 1 or 9. Aha, it's a divisor of 9. So 1 or 3. So just check back, please. So it's the check thing. Check technique makes it easy at this point. So we just check whether it satisfies this equation. Sorry, let me just put the number nicely on it. Sorry. So let's put that. So check C equal to 1 or 3. As you can see, the top one, 1 doesn't work. The bottom one, it works because C 9 over 3 square plus 3 turns out to be 4. So another solution here, 2, 1, 3. So it looks like 1, 2, 3 are the only solutions. 2, 1, 3, you know, the thing is now. So then we have the two answers. This one, the blue one here, and the earlier image. So those are the only answers. Thank you.